So at the end of the last lecture, we talked briefly about the graph of a quadratic function, right? And we saw that this graph here that I have on the left is kind of the base graph, and that's the graph of y equals x squared. So in this lecture, we're going to take this a little further and look at how we can graph some more complicated quadratic functions. And we're going to do it using the transformations that we learned about previously. So this is actually a really important graph that I want to take a look at. What does the graph of y equals negative x squared look like? Well, y equals x squared is our base graph, right? And the difference between that base graph and my graph that I'm trying to find is that minus sign, right? And you remember, again, from a conversation about transformations, putting a minus sign in front of the formula like that, it flips the sign on all the y values. So in the original graph here, all the y values are positive. The graph is strictly above the x-axis. In this graph, all of those are going to be flipped over and become negative. So we're going to take this, reflect it across the x-axis, and we get this graph here. And this is really a key point to focus on. We're going to come back to this repeatedly throughout our discussion of quadratic polynomials. If the coefficient out in front of the x squared, -1 in this case, if that coefficient is negative, don't care what's going on with the x and the constant term, the graph is going to be this upside down parabola. We call it, we say it opens downward. If the coefficient in front is positive, if it's a 3 or a 10 or a pi or a square root of 2, right, any positive number, then the graph is going to open up, unlike my graph on the left here. So how about this graph? Well, again, I'm going to approach this using transformations, because this is essentially the base function y equals x squared, but with that plus 4 inserted in there. Remember what adding a number to the variable, to the x does? Right, that has the effect of shifting the graph to the left, in this case 4 units. So the graph is going to move over here and look like this. Okay, so now I've got two transformations. Right, we've got a -2. That's going to be a horizontal, a side-to-side, a vertical. I was mixing those up. Vertical, side-to-side transformation. And then we've got that +1, which is going to be a horizontal or an up and down transformation. So that -2, that has the effect of shifting the graph 2 units to the right, and the 1 shifts the graph up 1 unit. Now, here's what I really want you to take away from this. Look at what happened to the vertex. Right? The original vertex was at the origin. It was at 0, 0. And the new vertex is over here at 2, 1. Well, compare that to the transformation numbers. Right? You notice that the new x coordinate of the x coordinate of the new vertex is a 2 when we have that -2 transformation. And the y coordinate is 1, and we have that +1 transformation. It's not a coincidence, right? That's not a coincidence. And in fact, that's what we're going to talk about some in the next lecture. So looking ahead, right, in the next lecture, we're actually going to change topics a little bit. We're going to focus on that vertex and look at a couple of different ways to find the vertex. If we're given just a generic parabola, if y equals 2x squared plus 7x minus 5, where's its vertex? We're going to see how to find that. And then in the lecture after that, we're going to circle back around to graphing again and look at the implications of being able to find the vertex with respect to finding the graph of a quadratic function.